Okay, so hi everyone. If you hear me, then please tell me. And today we will be talking about solutions from problems from A to C. I will also tell the solution to problem D, but only not an optimal one, only like size of the grid squared, right? Because it's the only thing that I know. Or maybe like n squared times m, something like this, I think. Okay. Yeah. So we'll wait for a bit and then we'll start. Someone asked what happened today. Your performance is not so good. Yeah. As I can show, well, problem B took me an hour because I had problem A after a minute. So it's not good. First I misread this statement. Then I switched my approach. There was a bit of chaos. And, well, it ruined my performance. Because problem D, as you can see, was kinda hard. Problem C is not DP. It's one observation and then brute force. Yeah. So, I think we can start. Wait, yeah, we can start. I will be back in a minute, I will start with A. I'm sorry, you can come back in 10 minutes or something. Okay, I'm back. I hope you still... you should hear me. And we'll start with problem A. I needed to tell my family to be a little bit more quiet. Okay. So in problem A, well, I think everybody solved this problem, but I will still tell the solution. In problem A, we are saying that we know that Nikita is putting cubes on top of the tower. And, well, in one move he can either put one cube on top of the tower or remove one cube from the top of the tower if there is a cube there. So they ask us if is it possible that after n moves the resulting tower has exactly m cubes. Okay. So we'll tell the solution to this quickly, because, well, I think everybody who entered the contest solved this. Or maybe, because it was even guessable from the, samples, I think. But we can see. Yeah, many people have solved this. So to problem A. Let's say that we have first, if m is greater than n, then the answer is obviously no, because I can put at most one cube in every turn, right? It's obvious. So I can't have more cubes than turns. And the other condition is that n modulo 2 needs to be equal to m modulo 2. Why it has to be like this? What is this saying? This is saying that in odd turns we will have odd number of blocks on our tower, and in even turns we will have even number of blocks on our tower. Right? How to prove it? Well, I don't know, by induction or anything. We see that in every turn we are either doing +1 or -1, so our parity always changes, the same as parity of round. So yeah. I don't know. Does anybody have any questions to this problem? Because I think you want to see some problem C, or maybe some of the problem B. Because problem B was solved by 2,000 people or something. No, probably more people. It's just system testing. Okay. Yeah. Does anybody have any questions to problem B? Problem A, I'm sorry. I don't see any questions. Yeah, it was super easy problem. Like, they want everybody to have at least one accept, right? So problem B. In this problem, we are given a number. Somebody is asking, what is the meaning of parity? Parity is the rest modulo 2. So it's even odd or... Okay, so problem B. In this problem we are given a number. So, for example, let's say 14. And we want to construct a sequence A such that, well, here it could be zero, minus 1, 0, 0, 1. And this is a binary representation, but with minus ones. What does it mean? It means that this bit is like a bit that corresponds to 1, this bit corresponds to 2, this bit corresponds to 4, this to 8, and this to 16. So we would take 0 times 1 plus minus 1 times 2 plus 0 times 4. Just like a binary representation, but with minus 1. I hope everyone understands how this works. So we want to construct such a sequence. We want to construct a sequence such that its sum is of course equal to x, but also there aren't two consecutive bits that are not zeros. So among every two bits there must be at least one zero. So for example, a equal to binary representation of 14. So 0, 1, 1, 1, 0 would not be good, because there are two consecutive bits such that none of them is 0. Okay. So I hope everyone understands the statement, right? Here we have our, vex or something. I don't know how to say it in English. Here we have like elements of AI, and here we have like weights. Oh, weights. Here we have weights. Like number of bit. Right? Okay. Okay. So, how to solve it? Let's look at the binary representation of x. Here we see it will be 1, 1, 1, 0, I think. Yes, it will be 1, 1, 1, 0, because this bit corresponds to 8, this 4, 4, like this. So we can't just copy this representation into A. So our observation is like this. If we have some interval of ones, let's say like this, it gives the same sum as something like this. It's the same sum. How to prove it? Well, it just does give the same sum, if you will think about it. And we see that here we only use the first and the last bit. So let's look at our binary representation of x and divide it into interval. And divide it into intervals. Oh, someone said, I also noticed that, but what is the proof behind it? Well, okay, let me think a minute. Okay, let's look at let's call this number A and this number B, right? So let's look at the difference between A minus B, okay? Well, we can look at the difference between every bit. So we will have a number like this. Here we'll have 2. What does this mean? Well, it means the same as if we would take our 1 here. Yes. But wait. Here we will have 2 if we look at A minus B. Here we have 1, 1, 1, minus 1. Oh, so now we can how to say it in English. We can move it to the left. It's like the same like with adding. So here we get 0 and here we get 2. Then like this. Okay. And we can do it further. Here we get zeros and here we get 2. Here we get 0 and here we get 2. And now when I will take it to the left, I will get 0 here, 0 everywhere. So difference between them is 0, so they are the same. I hope it's carryover. Yeah, it's carry. So we are just subtracting them and then carrying, and we see that it's 0. But this is a nice, kind of graphical proof. So now we have, now we could divide our binary representation. Let's say our binary representation looks like this. Into interval of consecutive ones. And for each interval, we could so here it would consider bits from 0 to 3. This one is from 6 to 6. This one is from 9 to 10, I'm sorry. And this one is from 12 to 13. So, if we have some interval of length smaller than 2, we can just put 1 here in our result, in our array A. But if we have length bigger than 1, then somebody says that they still don't understand how that proves it. Well, I just have shown here that A minus B is equal to 0, so A is equal to B. Right? I just subtracted them and do the carryovers, and I saw that, it's 0. But you can then replay the video. Okay. So for lengths that are smaller than 2, we will just put 1 there. And for lengths that are bigger than 2, or at least 2, we will do this trick with if we have interval 1, 1, 1, we'll do 1, 0, 0, minus 1. And we see that we won't have any 2 adjacent non-zeros. But there is this case here. 1, 1, 0, 1, 1. And in this case, I have 2 intervals that have length at least 2. So what I will do? I will do 1, 0, minus 1. And here, I will do 1, 0, minus 1. But now I have 2 consecutive same numbers, right? This is bad for me. So I will compress my intervals. If I have the situation like this, what I will do? I will put minus 1 in my array A here. Because putting -1 on this position is like adding 2 to the power of I into x, right? Because, well, I will subtract from my answer, so like add to x. It just works like this. So I will put 1 in my array here, in my array A here, and I will treat x as if its binary representation would be like this. So I will merge those intervals. And I will do this until I won't have a situation like this, and then just do my solution. So, does anybody have any questions? Yeah, I think the main trick was here to deal with this case. Okay, I will repeat it. But do you understand do you understand the solution without this corner case? Okay. So, how do I solve this special case? Let's notice this. If I will subtract 2 to the power of I in my solution, right? So I have my solution like this. 2 to the power of A0 plus 2 to the power of A1. Those are the number, or if I have the solution like this, 2 to the power of A0 plus 2 to the power of A1, etc. And at the end, I will subtract from it 2 to the power of I. And this has to be equal to x. I can like add 2 to the power of I to both sides. And what I will get the same thing here. But instead of subtracting 2 to the power of I can think about it like I would add 2 to the power of I to x. Right? Do you understand this part? Yes, I know. I'm sorry, because like I'm messing up the notations. So 2 to the power of P0 when this is the first position or something. Or let's say that I have my solution S, and from my solution S I am subtracting 2 to the power of I, right? So it's the same as if my solution would be the solution to x plus 2 to the power of I. Do you see this? S is the solution. So instead of thinking, when I put -1 here, instead of thinking like I would subtract it from my solution, I can think as if I would add it to x. Okay, so now we have this corner case that I shown here. If I will put -1 here in A, right, in our solution, then the binary representation of x will change to something like this. I will merge those intervals. Do you see it? If I put -1 here, I will add 2 to the power of I to x, so yeah. And well, I am merging those intervals like this until I won't have this corner case. And then I will only have something like this left. Our interval, some zeros. Our interval, some zeros. Maybe a short interval, a zero, a short interval, because I can have something like this. It doesn't mess up anything. Zeros and ones, right? So here, if I have like interval of length 1, I just put 1 in A. But if I have an interval of length greater than 1, then I put 1 here on the bit just outside of it, and minus 1 here. And zeros everywhere in between. As I shown before, it works, right? Well, yeah, I think this is a nice solution. Probably not the easiest one. I can say to you with like, I'm almost sure that it's not like the easiest solution. But it's nice. It has some good math concepts. Okay. So now to problem C, I think, or does anybody have? Yeah, I can show my code. It's also pretty complicated for problem B. Okay. Okay, so this weird word, przy, it's like intervals in Polish. I'm sorry for naming my variables like this. So here I am keeping the intervals. And, well, first I have some intervals. Okay, zoom, I'm sorry. Wait. Tell me if you will see it after zooming. Do you see it now? Do you see it? Because it should be much bigger now. Nice. So here are my intervals on the beginning, or before merging like this. Before this merging. And then what I'm doing. Until there is some change made, like if in the last turn of merging I didn't do anything, then I can stop merging. What I'm doing, I am checking if those intervals are like close to each other, and checking if the right one of them is like greater than 1, right? The left one of them, the size of the left one, they have to be, they're, in the case like this, I won't like to merge. So this is what this second part of if means. Then I'm putting it to new intervals, and everything like after it I'm also putting to new intervals and breaking. Otherwise I haven't met like a merger yet, so I'm just putting it. And if I haven't merged anything, then as I iterate to the not last but like one before last, I also need to push back the last interval. And then I'm just doing the thing that I said to you. I am putting the 1 on the beginning and minus 1 on the end. Or I'm just putting 1 if the length is 1. And here I have my asserts, because I had a book during contest and this was my way to stress test it. Right? It's a nice trick. I have generator and I just generate myself tests. This is problem B. So, does anybody have any questions, or are we going to problem C? If you have any questions, please ask them. Okay, I see that it's clear. So I think problem C now. Yes, sure, I will share my test case generator. I have a test case generator like this. This is my template. Like, just generate it like this. and you have a bash script like this or something. Like, there is some Erichto. I was learning how to stress this from this, so I think you should watch it. Oh, wait. Hello. It has weird sound, but it's good. So just learn, or maybe Cheyenne will do something. But I will still send this, because, yeah, this is a good material. Okay, so now to problem C. Or maybe you can ask Cheyenne and he will make a video about this, or maybe he already done that. So problem C. So in problem C, we want to find the longest special subsequence of A. And we define a special subsequence like this. We take the least common multiple of this subsequence, right? And check if it's in A. This subsequence is special if this LCM is not in A. Okay? Does anybody have any questions to, like, you know, statement? Or does everybody understand the statement? I see that everybody understands. Okay, so there's basically one observation in this task and one thing that you need to Google, or like Google to make sure that it's fast. Let's look at our array. Let's say that it's here. Let's sort this array. Now my observation is like this. I will prove it, of course. If there exists some element in this array, let's say that there would be some element like 27 here. So if there exists some element in this array such that it's not a divisor of the maximum, here maximum is 60 of course, then the whole array is a special subsequence, right? You can just see out n. Otherwise, it's getting interesting here. So, how to prove that if there is some element that is not a divisor of maximum, then the whole array is special? Well, I think it's kinda easy. We know that LCM is like, how is it in English? We know that if we will take the LCM from A1 and A2, it is smaller than LCM from, you know, A1, A2, A3, right? So if we'll take LCM of those two numbers, we know that it will be bigger than the maximum in this array. So it will for sure not appear in this array, as it's bigger than the maximum in this array. Right? Because, well, maximum is greater than this element, their GCD is not this element, because it's like not divisor, so it puts something new. Does everybody understand this? If there exists something that is not a divisor, so 27 is not a divisor of 60, then we can just see out n. Because our LCM will be greater than maximum. That's nice. So now we have a powerful tool. We know that, as it's shown here, everything in our array is a divisor of maximum. And we know maximum. So, how many possible LCMs do we have? Well, we have number of divisors. So, let's say that D of A, or or d of x is a set, or d from x is a number. Wait, let me just wrote it with keyboard. So we know that d from x is a number of divisors of x, right? So how many possible LCMs do we have here? Well, as everything here is a divisor of maximum, then we know that LCM of those numbers will also be a divisor of maximum, right? So we have only d from maximum, so here it would be d from 60, possible LCMs. And if you will go, I always forgot it, so I just wrote maximal number of divisors, and here's the article on Codeforces. I just always go here, scroll and go to always, and we can see that for 9-digit numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9. What? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we see that for 9-digit numbers, the maximum number of divisors is a little bit over 1000. So if we could do something like d from maximum times n, yeah, it's a little bit more than square root of the third degree. But if we can do something with complexity O from number of divisors from maximum times n, then we are set. It's now, because this will be around 10 to the power of 6. Because this is up to 10 to the power of 3, around 10 to the power of 3, and this is around 10 to the power of 3 too. So we want to do something like this, right? Does everybody understand up to this point? I will send you this also. Here. Okay. Nice. So now, well, this complexity shows us that we can iterate over every possible LCM and just check what is the maximal possible subsequence with this LCM, right? So let's find the divisors of maximum. We can do it in s squared from maximum, right? And let's iterate over every possible LCM. Let's say that we are in some LCM. We want to now say what is the maximal possible subsequence such that its LCM is x or a. A is our, LCM or LCM, just LCM. I say that if there exists a subsequence with LCM equal to our L, then we can pick all the divisors of this number contained in our array. Right? How to prove it? Well, first we want to find the maximal subsequence. So if we can pick some subsequences, right? It will be always optimal to pick the maximal subsequence. Second, we can only pick the divisors of this number. Because if we would pick something that it's not divisor, let's say 3, then we know that our LCM would be greater, right? So now we want to show that if there exists some interval such that its LCM is L, then the interval of... Well, we just want to show that the LCM of all the divisors is biggest, but I showed this before. This is this. right? It will always be, if we want to make our LCM as big as possible, and we want to do this with divisors, we don't want our LCM to be smaller, then we just will pick all of the divisors of L in this array, and that's basically just it. Yeah. So, we are iterating over LCM. We are checking if the LCM of all of its divisor in this array is equal to L. And then if it's equal to L, we are maxing our answer. Let me show you the code, because code is really clear here. We are checking if there is some element in our array tab, if there is some element in our array such that, well, our greatest elements, because I sorted it, is not divisible by it. If there is, then I see out n. Otherwise, I am finding the divisors, I am iterating over them, I am iterating over all elements of our array, and if my LCM is divisible by this element of array, then I am updating the number of divisors and updating the LCM, right? And if our LCM, after all, because our LCM can still be smaller. For example, in this array, let's say that we have picked an array of let's say that we have picked LCM, wait, let me think, 15. We have picked L equal to 15. Then what are the divisors of 15 in this array? 1, 3, right? But LCM of those two numbers is equal to 3. So we don't have any interval in this array, or any subsequence, sorry, with L equal to 15. So here we also need to check if our LCM, like, we have to check if our LCM is equal to the LCM that we have set, right? And this is basically just it. So, do you have any questions? Yeah, this was doable, I think. The key observation was that, well, if there is something that is not a divisor of maximum, then we can see out n. In the task from yesterday's rounds that I was doing explanation, and it will be uploaded soon, I think, there was also a task from yesterday's round, like task B from yesterday, I think. Let me see. Task B from yesterday round also was using that it's good to look on the maximum and minimum of the array, having a divisibility or LCM or something. I get that not necessarily taking all the divisors of L are in the array will yield the subsequence with LCM equal to L. But why do you have to necessarily check if it is equal? Dividing L is insufficient? Well, cause here with L equal to 15, you would found like 1, 3, which LCM is equal to 3 of these two numbers. And this is not a special subsequence, because 3 appears in the array, right? So that's why I need to check, because I could have found a non-special subsequence, and that's not what we want. You know. That's why you need to check. Because, okay, you know that if there exists a solution with this LCM, you will find it. But you may but there may not exist any subsequence with this LCM, and then you will found some other garbage or something, and you need to throw it out. Yeah. Also, you can ask me some questions, like, yeah, if someone have any question or something, now's the time to ask them. Also, remember that you can always replay the video, like, it's always saved. Well, the main idea was that if there is some element that is not the divisor of maximum, then you can see out n. Our whole subsequence is not a special subsequence, because the LCM is greater than maximum then. And so now we know that all the numbers in our array, if there is some number that is not a divisor, then we are counting n. If all of the numbers are divisors, then we have an interesting case. Can I step by step 3 to 10, 12, 20, 60? Okay, I can try. So let's look through the divisor of... Yes, so in interesting case, we are iterating over our LCM, because we have only the number of divisors of maximum possible candidates, right? And I have shown you on OAs that it's around 1,000. And the number of... And now when we have some LCM set, we want to see if there exists some subsequence with this LCM. And if there exists, we want to find the maximal such subsequence and max it out with our answer. How to do it? I say that it will always be optimal to take all of the divisors of L, right? Well, you just check every possible LCM, like you just iterate over every possible divisor in your loop, and check, and take the maximum of all answers, right? So now for some LCM we want to find the maximal answer. First, we check how many there are divisors of this LCM in our array. And if the LCM of all of those divisors is really equal to this LCM that we have set. Because otherwise we could just, well, have situation like this, like here. We are taking L equal to 15, we have like 1, 3 that are divisors, but their LCM is equal to 3, which is not a special subsequence. My account name on Codeforces is like this. You can see it in the... Look, you can see it here. Okay. I hope you understand now. You can also replay the video. What path do I prefer if someone starts Codeforces? Thank you. You can also write in our server, in Shank server. What path do I prefer if someone starts? Well, Codeforces. Well, I was starting in my school. I had classes, so I am not really like I wasn't learning by myself. So that's I don't have like a big expertise over this. So, does anybody have any questions? Or anything to say about the stream or anything? Yes, I am in second grade of high school. And I am from Poland, if someone doesn't know. Thank you. Yeah. So thank you for watching this. I think the video editorial of the previous round should be uploaded anytime now. And stay tuned for more on the channel. And also try to absolve the tasks that you didn't solve, because it's educative. Educative. And see you next time.